Homework 2.3, Linear Functions and Slopes, Video 8. Before I go to the board, I just want to warn you that my tripod is acting a little goofy, so if the video tilts a little bit or slides a little bit in the middle of it, that's why. If I go to stop recording and notice that it's just slanted so far, I will have stopped and recorded it over again and probably said some words that I shouldn't record in between. Okay, so we're going to take a look at horizontal and vertical lines, and this isn't our first foray into them. When we first were looking at slope at the beginning of this series of videos, we had decided, or discovered I should say, that if you're a horizontal line, your slope is 0, and if you're a vertical line, your slope is undefined. But we're not really talking about slope specifically, so I guess a better title of this video should be Equations of Vertical and Horizontal Lines. Now, one of these is not a function. Which one fails the vertical line test? Well, I'll give you a hint. It fails it miserably when it fails it. It's not this one. Any vertical line will only hit this once. It's this one. Most vertical lines miss it, but when it hits the whole thing, so it hits it an infinite number of times. So this one's not a function and this one is, which means we can write one of them as f of x equals and the other one we can't. So which is which? Well, first let's find the equations and then we'll figure that out. Oh, which one can we write as f of x? The one that's a function. We can't write this one as a function because it's not. But anyway, let's get back to finding the equations of the lines. One thing you can say generically about equations is that they describe what every point on a graph has in common. For example, if we graphed y equals x squared, then for every point on that parabola, the y is equal to the square of the x. So we're going to find the equations of these lines by asking what every point on each one has in common. Let's start with this horizontal line that has a y-intercept of 5. And let's pick a couple of points. Can you tell me something that those 2 points have in common? Are their x's the same? No, because one is to the right, one is to the left. But the y's are the same. I don't know what this x equals, but the y equals 5. And I don't know what this x equals, I know it's negative, but the y equals 5. And it doesn't matter what point we pick, we can always say that the y equals 5. I pick this point, y equals 5. I pick this point, y equals 5. I pick a point way over here, y equals 5. Guess what the equation is? What do all the points have in common? Y equals 5. The equation of this horizontal line is y equals 5. And believe it or not, this is consistent with slope-intercept form. Because what's the slope of this line? This horizontal line, its slope is 0. So we could write it as y equals 0x plus 5. It's a little silly to write what's not there. But if we did, it would confirm that the slope is 0 and the y-intercept is 5. But 0 times anything is 0, and then of course 0 plus 5 is 5. So it's kind of silly to write it completely in slope-intercept form. This one can be written as a function, because remember the output of the function is the y-coordinate, so you can always replace the variable y with f of x. So we could say f of x equals 5. So from a function perspective, it says give me any x you want. Once you picked one, go up 5. Pick an x over here, go up 5. Pick an x back here, go up 5. Pick any x you want, go up 5. So let's generalize this. The equation of a horizontal line, and let's talk specifically about its y-intercept, with a y-intercept of b, since that's the letter we use for y-intercepts, is y equals b. So all you have to do is say y equals whatever the y-coordinate is. What do you think the equation of a vertical line is? The equation of a horizontal line is y equals. So you think the equation of a vertical line is x equals? Let's check. On this board, I have a vertical line drawn with an x-intercept of -3. So let's play the same game we played over there. What can you tell me about this point's ordered pair? I don't know its y, but it's x equals -3. And what can you tell me about this point's ordered pair? Again, I don't know its y, but it's x equals negative 3. And it doesn't matter which point I pick, x equals negative 3, x equals negative 3, x equals negative 3. So what do all these points have in common? X equals negative 3. And that would be the equation of this vertical line. Can we get this in slope-intercept form? Nope. Why? Slope-intercept form starts y equals. There are no y's here. But there were no x's there, and you inserted one with a 0 in front. All right. Let me insert a 0y here. Solve that for y. Go ahead. Dare you. Your last move is to do something you're not allowed to do. It would be divide by 0. So we can't write this one in slope-intercept form, but we weren't supposed to, because if we could, then we could write it as a function, and it's not. It violates the vertical line test. So how can we generalize this? The same way we generalize the equation of a horizontal line, but instead of talking about its y-intercept, we're going to talk about its x-intercept. So the equation of a vertical line with an x-intercept. Now, I don't want to call it b, so I'm going to call it a. And this is actually the reason the y-intercept is called b, because in a general discussion of intercepts, the x-intercept is called a, and the y-intercept is called b. And now you know. So the equation of a vertical line with an x-intercept of a is x equals a. All you have to remember is vertical is x equals and horizontal is y equals. All right, so not a whole lot to talk about there except the fact that their equations are easy. Go try questions, I didn't write it up there. Go try questions 17, 18, 19, and 20. Gee, there are 4 questions and there are 2 types of problems. I wonder how many are horizontal. I wonder how many are vertical.